Okay, welcome again to Bright Brain City Grass. Today we are solving a wonderful factorial challenge, which says z to the power of 2 plus 19z equals to z factorial. So how we're going to solve this? And the questioner says z is equals to what? So we are looking for the value of z in this challenge. So if you are new to this channel, you can kindly do it by clicking on the subscription button and the notification bell so that you will get notified anytime I release videos on maths, because in this channel I solve problems on mathematics. So let's see how we can dissolve this maths factorial challenge. Okay, having said and done, we can say solution. Okay, then we can simply write down our question which said z to the power of 2 plus 19z is equals to, we are having z here, z equals to z factorial. The word factorial actually means a form, mathematical form way of expanding a particular figure or expanding a particular number. Take for example, in factorial actually is found in a topic in mathematics called the binomial theorem, or what's called the Pascal triangle. So the word factorial actually means the way of factoring out, or the way of expanding a particular figure. Take for example, if we have 0 factorial is equals to 1. Now if we have 1 factorial is also equals to what? 1. If we have 2 factorial is equals to 2 times 1, right? We are having 1 here. If we have 3 factorial is equals to 3 times 2 times 1. Now if we have 4 factorial is equals to 4 times 3 times 2 times 1. If we have 5 factorial is equals to 5 times 4 times 3 times 2 times 1, and so on and so forth. So if you have 6 factorial, we are saying 6 times 5 times 4 times 3 times 2 times 1. If you have 7, you do the same for 7 till the number you are desiring to have. Okay, having said and done all that, we are now having z to the power of 2 plus 19z is equals to z what? Z factorial. Okay, having this, so what are we simply going to do? We can see that at this junction, at the left hand side, we are having z here and we are having z here. In other words, at this left hand side, z actually is common. So what are we going to do? We can factor out the z out. So factoring out z, we can say z will cancel off this, we are left with z, plus z will cancel off this, we are left with 19, close the bracket, is equal to what? Z factorial. This actually is z. Okay, having this, we cannot see that this, we are having z here, we are having z here. So what are we going to do? Okay, remember I gave you some mathematical expansion on some value. Take for example, we are having 1 factorial. 1 factorial is equals to 1, 2 factorial is equals to 2 times 1. Then I want you to see something at this junction. Seeing something at this junction is that by the time we are having all this value, you can see that by the time we are expanding them, they are not decreasing by 1. You can see for example 3 now then decrease to 2, 2 then decrease to 1. In other words, each of them, by the time we are expanding them, one of them, they are going to be decreasing. So in other words, the formula for the general factorial, therefore n factorial is equals to n, open bracket, n minus 1, close bracket, to the factorial of it. In other words, if you are plugging 2 in the place of 1, so we can say 2 factorial is equals to, what is your n? 2, open bracket, 2 minus 1 factorial, right? You can simply say 2 times what? Times 1, 1 factorial. And we said 1 factorial is equals to 1, so 2 times 1. So this is exactly what I'm trying to say. In other words, so in the place of z factorial, what are we going to put? So we are going to take z. We are going to take z. So let me quickly erase this part. So we are going to take z to be equals to z, open bracket, z minus 1, close bracket, factorial, z factorial actually. So z factorial. So z factorial is equals to z, open bracket, z minus 1. So this part we are having z factorial equals to z, open bracket, z minus 1, close bracket, to the factorial. So in place of z factorial, we are putting the whole of what? The whole of this. So we are going to have z, open bracket, z plus 19, close bracket, equals to z, open bracket, z minus 1, close bracket, and the factorial. Okay, we cannot see that at the left hand side we are having z, and at the right hand side we are also having z. So what are we simply going to do? We are going to cancel off z. So cancelling off z, we are going to divide both sides by z. So doing that, we can say divide by z, divide by z, by z. So by the time we do, this and this can go off, this and this can go off. So what are we left with? We are now left with z plus 19 is equals to z minus 1 of the factorial, right? Okay, after doing all this, we can now say z plus 19 is equals to, open bracket, z minus 1 to the factorial of what? Of it. Okay, we are now having another challenge, because at this point now, we are not having a factorial, because z minus 1 to the factorial of this. So how are we going to look for the value of z? Having this. Okay, the next thing we are going to do, we are going to take z to be equals to a particular number. So what are we going to do? We can say, coming here, we can say, let's say z minus 1 equals to b. Let's say z minus 1 equals to b. In other words, making z to be the subject of formula, we can say z is equals to b plus 1, right? Okay, in other words, whenever we see z minus 1, we are going to put b. Then whenever we see z, we are going to put b plus what? Plus 1. So coming here, we can say b plus 1 plus what? Plus 19 is equals to what? What is z minus 1? Z minus 1 is b. So we are having b factorial. Is it not awesome? Okay. Having all this, we can simply put in our value. So putting in our value, we can say b plus 1 plus 19 is going to give us 20 is equals to what? B factorial. This thing is getting interesting, because we are not left with b plus 20 is equals to b factorial. Okay, so let's see how we are going to resolve out b. By the time we've done resolving b, then we can now go on ahead and resolve the value for z. Okay, since we've gotten b plus 20 is equals to b factorial, so what then are we going to do to look for the value of b? Then we'll move on ahead to look for the value of z. So we are going to think of a number. By the time we plug in that number at this point, the factorial of that particular number is still the same with the sum of the two numbers at this point. So what are we going to do? We are going to think of a number. Let's think of 1. If we say 1, so let's say b is equals to 1. If we say b is equals to 1, if we are putting 1 here, 1 plus 20 is going to give us 21. Then we take the factorial of 1. Factorial of 1, remember, is equals to 1. So 21 is not equals to 1. So the factorial of 1 can't work. So b can't be equal to 1. Okay, let's think of another number since we have used 1. Let's think of 2. Let's move ahead and use 2. Let's say b. Let's assume b to be equals to 2. If we put 2 here, 2 plus 20 is going to give us 22, right? Equals to, let's take the factorial of 2. Factorial of 2 is going to give us 2 times 1. And 2 times 1 is going to give us 2. So 22 is not equals to what? It's not equals to 2. So b can't be equal to 2. So let's think of another number. Let's try 3. If we should put 3 here, 3 plus 20 is going to give us 23. Then we'll take the factorial of what? 3. Taking the factorial of 3, factorial of 3 is going to give us 3 times 2 times 1. And 3 times 2 times 1 is going to give us 6. So 23 is not equals to 6. So b can't be equals to 3. Okay, then let's try for 4. If we should put 4 here, 4 plus 20 is going to give us what? 24, right? Then if we put 4 factorial, 4 factorial is the same thing as 4 factorial is the same thing as 4 times 3 times 2 times what? Times 1. So 4 times 3 is going to give us 12. 12 times 3 is going to give us 24. 24 times 1 is going to give us 24, right? So 24, we are having 24 here, and if we should put 4 here, 4 plus 20 is going to give us 24. So 4 actually is going to work. So if we put 4 plus 20 is equals to what? 4 factorial. And we are having 4 factorial to be equals to 4 times 3 times 2 times what? Times 1. So we can say 24 is equals to 4 factorial, right? And 4 factorial is equals to 24. So 24 is equals to what? 24. Because if we are taking the factorial of 4, the factorial of 4 is 24. So 4. So b is equals to what? Is equals to 4. So the real value for b is 4. So since we've gotten the value for b now, so since our b is equals to 4, then what then is our z? Remember we said z minus 1 is equals to what? To b, right? So we can look for z here by saying z is equals to what? B plus 1. Making z is solving the formula by bringing this one to the right hand side, and by the time this one is crossing the equality sign, it's going to turn to what? To positive. So we are having z here, we are having z equal to b plus 1. So what then is your b? Your b is equals to what? Is equals to 4. So z is equals to 4 plus 1, which is equals to 5. So my z is equals to what? Is equals to 5. Amazing. So let's now prove that the value of z is actually correct by going back to our first question, which said z to the power of 2 plus 19z is equals to what? Z factorial, right? So in the place of z, we are going to put 5. So we are left with 5 to the power of 2 plus 19 times what? You can put a bracket, 5 close bracket is equal to what? 5 what? Factorial, because we are saying our z is equals to what? Z is equals to 5. So we are putting 5 factorial. So we are saying z 5 to the power of 2 is going to give us 25. 25 plus, and 19 times 5 is going to give us 95. So we are left with what? 95 is equals to what? 5 what? 5 factorial. Okay, since we are not having this, we are saying 25 plus 95. 25 plus 95 is going to give us 120. So we are left with 120. 120 is equals to what? 5 factorial. So what then is 5 factorial? 5 factorial says 5 times 4 times 3 times 2 times 1. And 5 times 4 is going to give us 20. 20 times 3 is going to give us 60. 60 times 2 is going to give us 120. And 120 times 1 is going to give us 120. So 120 is equals to 120. So we can say 120 equal 120. So the value of x actually is the value of z actually is extremely correct. So if you love this video, you can kindly do well by clicking on the subscription button if you have not done that, and hit up the notification bell so that you get notified anytime I release amazing challenges on mathematics, because in this channel I solve problems on maths such as calculus, algebra, Olympiad mathematics, and different branch of mathematics. Remember, Fego loves you, the people of Bright Brace Integrals loves you, and we all love you, and we all love to see you in our next video. God bless you, and Jesus loves you. Thank you, thank you, thank you.